All right, after resetting that 3 times, it looks like we've got power. So this is application programming with Java. The class is sort of misnamed. We're probably only going to spend about 3 weeks on Java, then we're going to jump right into Android. All right, just so you're aware of that. Same meeting time as last semester. Those of you who were in the ASP.NET class last semester will meet in this room. Nothing new in there. Now, what we're going to do today, and what I should do, in fact, what I will do. Now, on the syllabus here, I'm going to go over a couple PDFs right now. All right? And they're both from IBM. They're both on Java language basics. We're going to go over those. Then, I'm going to go over this thing right here. In fact, let me just grab all of them. The first one is Introduction to Java Programming, Java Language Basics. So you're just going to get a bunch of stuff thrown at you. Then more advanced Java features. All right, a bunch more stuff thrown at you. But we're going to spend a lot of time in the next couple weeks going over this. What I'd strongly suggest right now so again, this is the table of contents, so we will start on that today. Hopefully, by the time today ends, or halfway into the period, or whatever, you all will have loaded at least the IntelliJ IDEA and the Java JDK. All right? Because I'd like this to write some programs as a class. If for some reason you're having a problem, or if you're like my new student this morning, who evidently wasn't told he had to bring a computer with him, all right? And if that's the case, I will be taping this, but the programs that we're going to create today, it's your first assignment. Did you hear that? I'm actually giving you hard copies, and I'm just going to ask you to key those 3 in, just so we can get started. I know, but I'll tell you what, there is, and Devin, you're a really good person to like talk to about this, because last semester to this semester, I have never seen so many sleepy-looking people in my life in a classroom. And you don't mention the name because I'm taping, but your bud was one of them. But there is another person who sits basically right across from him, who spent the whole period like this with their head down. You know, and I'm to the point where I'm not sure what, if anything, I should do about it. Now, the guy we were talking about, the first guy, that it was just for a couple minutes. It was, that, but the other person was most of the period. That's a problem. I mean, what are you going to do when you get on the job if you're going to be like that? I don't know. So we're gonna start going over this, but I don't see that in you guys. Maybe it's because it's noon, and even if you slept until 11:30, you're awake now. I don't know. All right, is that flash drive still making its way around? Okay, and that's fine. But what I want to show you is what's on here. If you look up on the screen here, all those written tests that I just mentioned to you, they're there. And the other one, these are PowerPoints I created. All right, Paul uses Prezi. I like Prezi better than PowerPoint. My wife was watching me work on Prezi last week, and I've never had this happen. I'm in the middle of working on a file, and all of a sudden, literally, the screen goes blank and the file's not there. Even though I'd saved it a bunch of times already, it's just not there. And I was getting so miffed, I said, the hell with it, I'm just doing PowerPoint. So for the Java part of the class, I'm going to talk PowerPoint at you. All right? So you've got that. Bless you. Plus, and I thought I put that on there, but we'll see. You've also got, there's some PowerPoints from a Muroc Java book. All right, so let's take a few minutes and go over the syllabus. Again, most of it is stuff that you've already seen, right? I mean, it's different because this is Java. Now, if you look here on the bottom of page 1, this is what you're supposed to get out of this. Utilize widgets, layouts, and styles in Android apps. Well, of course, that won't be right now. That'll be starting in about 3 or 4 weeks from now. All right? Write apps that demonstrate Java and object-oriented programming. We'll start that today. Plan, design, build, and test mobile Java-based apps using Android Studio. That'll be in a few weeks. Work with the Android SDK, Gradle, etc. That'll be in a few weeks. Now, I got to mention this because perform file I/O and continue to use Git. Now, you probably have already heard this, but my daughter came from Illinois over the break with her boyfriend, and they were good enough to leave the flu with them. So I've had that ever since Christmas. I'm getting better, believe it or not. It may not always sound like it, but I'm better than I was. I can't take taking meds anymore. You know, I'm tired of doing that, and I get sleep, but I wake up and I feel just as bad. All right. Important dates. We just quickly write these down. 2 weeks from today is 1/21. That's Martin Luther King Day. Last week we only had a week, and then you had the next Monday off. This year it's 2 weeks, and then Monday. Did you hear that? 2 weeks from today, no classes, school closed. All right? Then the following month, 2/18. That's a Monday, that's a Monday. That's President's Day. We're off for that one. Then, 3/11 to 3/15. That's the break. All right? Finally, 4/19. I wrote this before, and I'll put a caveat on there. If you're an atheist, sorry. If you're a Muslim, sorry. But I still refer to it as the Good Friday break. All right? But that Friday, there's no class. And finally, 2 more things. Wednesday, 5/8. That's the last day. And Saturday, 5/11. That's the graduation. All right? So those are the important dates. If you want to write them down, fine. If you don't, I don't care. But I'll leave them up there at least for a bit. All right? Attendance. Hopefully we don't have to go. Well, that was pretty neat. I'm looking up here. Look at this. The class meets until 4:25 a.m. Yeah, I think I ought to change that. Maybe put a P there. All right. So please stay until then. You know the rules. You know we meet 5 times a week, so that you know you get up to 6 absences. One of the reasons that I was a little, not late, but I got in here right as class started is Charles and I were talking. I told you he was in St. Louis last semester and he's here now. And I told him, I said, Charles, do you realize that if somebody comes to class every day, but so they come literally every day, but they can have up to 12 tardies and still be in the class. He said, yep, I do. Said, okay. Now it used to be we just counted tardies as tardies. So you could have been late every day, and as long as you came every day, you would have no absences. But we were talking about the fact that, and not everybody, I don't think you guys are like that. You're professional, but there are people that are in the programs right now that are like they feel entitled. What do you mean you're marking me as tardy? I was only 15 minutes late. Really? Wow, is that going to work on the job? All right, and you know that 2 tardies equals an absence. Okay, there are no excused absences. I expect you don't cheat. The grading scale, if you look up on the screen, this has changed. Look up here. It's the weight of this. Your written tests are only worth 10%. So no matter how many points they are, when I get done, I'll multiply it by 0.10 or whatever, but it's 10%. All right? 30% is on the programs that you'll get for homework. 50% will be on your hands-on tests, and you'll have a final project, and 10% will be on your updated portfolio. Any questions on that? Hopefully that's pretty self-evident, okay? I think I mentioned this to you last semester, but on the off chance I did not, Jeremy Sutton has left Rankin. He's been replaced basically by Brandon Fan, but Brandon's a lot of his duties are kind of up in the air right now because he came here from St. Louis, and I don't know if he's tying up loose ends. So if you have questions on anything, you know, you get into an accident, you can't reach me, you're worried about whatever, call Patrick. Patrick Glenn. Does everybody know who Patrick is? Okay. I probably should have told Patrick that I'm putting him down as a contact, but I never did. All right, snow days. You know, we had one last semester. And is everybody signed up for Inside Rankin? Yes? All right, then we don't have to talk about that anymore. Again, as they say, unless you're notified then, assume class is going to be held. All right? So I'm going to very, very quickly, I mean 5 minutes. All it's done right here, if you look up on the screen, all it's done here, all it's done is the first 3 weeks. All right? And Mr. Smith may be a little agitated with me because I was supposed to get more done during the break than I did. But I'll tell you, like I said, everybody who says to me, yeah, man, if you had that flu, it really knocks you out, I'm thinking, yeah, whatever. It does. Now, I don't say that anymore because having had it, it does. You just don't sit there and feel like working on a computer for 8 hours. And if you don't know this, because this is the first time I've done this since I've been here, Charles let me take off last Wednesday, Thursday, and Friday. My break was your break. I was off 16 straight days. So it worked out nice for me. All right. So we're going to look at these PDFs in just a minute. All right. And what I want you to do is to go for class tomorrow is to go to the Java Trail and look at lessons 1 and 2. It's got their complete programs 1 through 3 due at the end of the class tomorrow. We will work on those later. All right, you'll get some time today. You'll get some time tomorrow to work on those. All right, I'm not going to read this anymore. You can see the stuff that's in here. So tomorrow, Tuesday, we'll go over Java Trail, lessons 1 and 2. And I'm going to give you a couple more programs. Much of the first 3 or 4 programs, you're going to be like, we already did this stuff. Yeah, but you did it in C#. I want you to see some of the differences in Java. All right? Notice Wednesday, I've got their lab all day. So that should give you plenty of time to finish up any work you've got to finish up. Thursday, we'll go through lessons 3 and 4 of this Java Trail. And you'll get a couple more programs. Friday, lab all day. All right? Going to the next week. So a week from today. Going over, finishing up 5 and 6, whatever's left. On Monday, more programs. Lab day, lab day, lab day. Notice what I'm going to try my best to do, is a week from Thursday, the 17th. What I'm going to do is I'm going to give you a pretest. You don't have to turn it in, but it'll be very similar to what your test will be. Does that make sense? And I'm going to say, do this. I'm going to give you till about 3:30. Then I'm going to go over what I did. Does all that make sense? All right. Then a week from Friday, the 18th, you will have your first test. It will be a hands-on test. I don't mean these written tests. I mean your first hands-on tests. No class 2 weeks from today. It's MLK Day again. Then we will go over the last 2 lessons, 7 and 8. You will get some kind of a project that I have not created yet. And you will have basically a week to finish it. All right? And you will have lab day, lab day, lab day. So you'll have about 2 or 3 lab days to work on it, and then we'll have 1 more test. All right? If I have time, I'll give you a pretest before that one. Then if you look on the screen here, notice what it says, to be provided. And it's just all blank, except for the days that you have off. I'm going to try by the end of this week to have this whole thing filled in. I'm going to do the best I can to get it filled in. All right? Questions on anything on the syllabus? Anything. All right. Then I'm going to jump over to this. All right. If you want to bring this up yourselves, All right, let me go back. Where is, oh, of course I just closed that, didn't I? All right, I'll leave that up here for just a second. I'm going to right now go over the Introduction to Java Programming Part 1. Then I'm going to go over the Introduction to Programming Part 2. Then we're going to look at Part 1 of this Java Trail, Learning the Language. So, does everybody get that 4 weeks from today, which comes out to be 1, 2, 3, the 4th of February, is when we will start on the Muroc Android book. Does that make sense to everyone? What I'm leaning toward right now is, I think I told you this last semester. Devin, you may not have heard this, but I took a class online with this guy. What he did, which I thought was pretty ingenious, it was a class in learning Android. And the first thing he did was he created the equivalent of his resume as an Android app. Everybody with me? So I give you that. Okay? And so you get the finished product. Then what we'll do is we'll take that finished product, rip it apart, and put your information in there. That make sense? All right? Then after we get done with that, we'll rebuild it from scratch. Does all that make sense? Then we'll go actually into the book. So Paul's people may be ahead of ours. All right? I don't have any idea how he's going to do this. All right? That's his call. But I think it's important that you have at least somewhat of a foundation into into Java before we start going on. You may or may not agree. And I will tell you, if you think, at 9 weeks, remember how 9 weeks last time I gave you my own course eval? I'm going to do that again at 9 weeks. And if you think this first 3 weeks was just a waste of time, write that down. And if I get that from every one of you, I probably won't do this next time then. All right? All right. So this is the one. Even if you just bring up this one, you can get to the other one from this one. But that's the one that I'm going to bring up first, or I'm going to talk about first. I'm going to talk about this, but I'm going to talk about it kind of in generalities. In other words, I don't think you can learn a language until you start writing programs in the language. You may agree with that. You may not agree with that. But for me to sit up here and just lecture and you not do anything is a waste of both our times. Does that make sense? What I should have done is just grabbed this and emailed it to you. I don't even think I have a list set up right now, so what do we got here? We got I'm going to give you all of these. There, you've got them all now. Just sent. All right. There is a chance that my sound was off. Well, that's really great. So, we're going to start right now on part 1, Java Language Basics. Again, this is done by IBM. You can go out and you can find hundreds, if not thousands, if not more of these articles. All right, I went and looked for a couple that I thought were pretty good, and they're both about 50 pages long. So we'll go through this one. If we can get it all done before the break, fine. And if we can't, we'll sneak a break in there someplace, and then we'll finish it up. Then we'll go over the next one. All right? Then I'm going to go over part 1 of this Java trail, and then we're going to look at some code. Does all that make sense? All right, so taking it from the top. It says here, this first part is a step-by-step introduction to OOP using the Java language. Part 2 covers more advanced features. All right. Now, there is several things in this tutorial, if you look up on the screen, that suppose you are using Eclipse. Eclipse is an IDE just like IntelliJ that I told you to do is an IDE, just like Visual Studio is an IDE. All right? If you decide after we start using IntelliJ, if you're thinking, I don't really like this, and you want to try something else, if you want to try Eclipse or something, you can do that. All right? So I'm not going to go through any of the stuff that's in here for Eclipse, is what I'm saying. All right. Java is an entirely object-oriented programming language. That's the first thing. Second thing, anybody remember from the C# class? I know it's been a while, but from the C# class, is there anybody who remembers what is the name of the method that you use to get into a program? In other words, what method must every C# program have? Main. All right? And it's not that this is a big thing, but just to tell you, when you create main in C#, it's a capital M. In Java, it is a lowercase m. Everybody hear that? May not sound like a big thing, just so you know. All right. Now, Java is a little bit different. What we're going to learn to do right away, and that's one of the reasons I like IntelliJ, is we're going to set up packages right away. You'll begin to create a project. When you create a project, basically it's going to create a folder for you with the name of the project. Make sense? All right? And we'll do that, but then inside of that folder, we'll create a package. A package is kind of like a folder within a folder that's going to hold most everything you have. All right? Then inside of that package, we'll be creating other stuff. And it's really and truly simple. All right? Now, am I right in assuming, just as an example, I'll assume, let's just say that I was one of you in here. Matt, you got a shorter name, I guess. Are you like Matthew underscore Purcell at Inside Rankin?
I think so, yeah.
.org? All right. Now, what I'm about to show you, it's not that this is mandatory, but what most people end up doing in most companies is they use what's called reverse domain notation for their packages. So in other words, for Matt, when it asks for the name of his package, he's going to write org.InsideRankin.Matthew underscore Purcell. And I'm going to expect you to name all of your packages like that. Does that make sense? It's not that that's mandatory, but that's pretty much the way that most companies do it. That eliminates collisions where two programmers could be working together and possibly use the same kind of, the same variable names or whatever. It makes sure that a lot of that stuff does not happen. All right. Java's a kind of weird language in some ways. You may or may not be aware of this, but in virtually every programming language that I know, that both interprets and compiles, you with me? In virtually every language I know, it does the interpreting first, then it compiles. Java compiles first, then it interprets. When you go and compile a Java file, so let's say, the first one that we're going to create today, we're going to do a payroll program. And you're going to have a file that's called payroll.java. All right, or something like that. When you go and compile it, when you go through it and you compile it, if it works, it's going to create a file that's called payroll.class. All right, that's a file that's called bytecode, and it's designed to run on any system. So you can take it, if you take that file, and a lot of times you can bring it like onto a Mac or an Apple machine and run it, not change a thing, and it'll run. But then that file is the one that gets afterwards interpreted and run on your system. All right. Then they talk about the JVM. A lot of this stuff, it's weird terminology. JVM stands for Java Virtual Machine. Virtually every laptop computer, desktop computer, I don't know about tablets. I'm not well versed enough in that to say, but virtually every laptop and desktop that I know of, regardless of whether it's a Linux box, an Apple machine, a Windows machine, whatever, in the last 15 plus years has the Java Virtual Machine in it by default. All right, and the Java Virtual Machine is basically what allows this compiling and then interpreting to take place. If you want to read more about it, you can read on here. I'm not going to read anymore. All right. Next, they talk about the garbage collector. What Java does, and I may have used this analogy before in other classes. I don't know. But has anybody ever seen this? You don't do it as much today. But like when I was your age and I was going to college, all right, I would park in a 2-hour parking space. And every once in a while, a cop or somebody would come by and they draw with a chalk mark under your tire. And then they'd come back later. And if that chalk mark was still there, they'd give you a ticket. Does that make sense? All right. I know it doesn't exactly work like that today. But where I used to park, I parked far enough away from campus, I didn't have meters. But it was only 2-hour parking. Reason I'm telling you that, that's kind of what Java does. Is if you're using a variable, Java, as the system keeps running and running and running, it'll check and says, oh, Evan's still using that variable. Oh, he's still using that variable. Wait a minute, he set it to null. He's not using it anymore. So that it's like he puts the chalk mark there. When he comes around and checks it again, oh, still not using that variable, then it gets rid of it. That's what the garbage collector does. It's a very low priority thread that runs under the control of the operating system, just so you know. All right. Then, I know you'd asked about this a little bit, Tony, directly or indirectly, but the JDK, the Java Development Kit, all right? As it says, when you download the JDK, you get the compiler, you get a class library, you get a boatload of stuff, all right? It says the best way to get an idea is to check out, the documentation. So, one of the things that you get is the JRE, or Java Runtime Environment. Notice what it says it includes. The Java Virtual Machine, code libraries, and stuff that you'd need. All right? Do you remember, I'm asking you this, when we talked about APIs, an application program interface, one of the things that we said about an API is it's like a big contract between you and the software. All right? Where the software says, I'll do this stuff for you, and then you say, fine. Then I'll do it the way you want me to do it. All right? So why am I telling you that? Look up on the screen. If I type up in here Java API and hit enter. Java API, Oracle Docs. Now, if I come through here, look, you got to look at this, please. These are all the different packages that you've got available to you. All right? So, for instance, let's see. There's java.io, input, output. So I click here. And then it shows me everything that exists for interfaces and classes under Java.io. See that? Well, I want to use a file writer. So I click here. Then it shows me over here in their documentation how to use it. That make sense? Now, the newest Java that's out there is Java 11. But as far as I know, the newest API that's out there is 8. The point is, you might want to type in Java API and take a look at it, and if you think it's important enough, bookmark it. All right. So they talk about, right here, how to install the JDK. So if you haven't done it yet and you're looking for some help, all right, that's a way that you can do it. You can go out here, you can grab the newest one. 1.8, I don't know if that's not the newest. But if you do go out, the easiest way, of course, is to go in and Google download Java JDK. All right? My guess is every one of you's got a 64-bit machine. Make sure you take the newest stable version that's 64-bit for Windows. All right, I'm going to skip this whole next section because it's on Eclipse, so I'm not going to go over any of that. What you're going to find when we start to go over IntelliJ is the way that IntelliJ works is virtually identical to the way Eclipse works. All right. So I'm jumping all the way down to the bottom of page 9. Object-oriented programming concepts and principles. You may or may not remember chapters 9 and 10 of the C# book were on object-oriented programming. You have heard these fundamental things before. You should know what a class is. It's a blueprint from which you can create objects. Kind of like a house plan from which you create houses, right? Same kind of an idea. What's an object? It's an instance of a class. The act of creating an object is called instancing or instantiation. An object is an entity that contains or can contain both data and ways to manipulate that data. Remember when we talked about having a person object? And we said, for example, a person could have a height and a weight, an eye color and a hair color. That'd be their data. A person can eat and drink and sleep. That'd be their methods or their behaviors. But everybody eats different things. Everybody sleeps a different amount. Everybody drinks a different amount and drinks different things, etc. So the object, no pun intended, if you look up on the screen here, a well-written object has 3 different things. It has well-defined boundaries. You know what it does. An object can only do what you say it can do. All right? I mean, I still remember this. This was many years ago, giving a lecture. It was in a systems analysis and design class, and we were talking about this kind of stuff. And I said, we talked about a person class. And he said, okay, what can a person do? And, we said like eat and sleep and drink. We put down a few things. And then somebody, of course, had to have the, raise their hand. They had the wild idea. Well, what about fart? All right. And he said, no, this person right now, as it's written, cannot do that. Because the object that you create only can do what you give it the power to do. That should make sense to all of you. All right? So it performs a finite set of activities. It knows only about its own data and, any other objects that it needs to communicate with. So here's an example, a person object. And guess what? Take a look in here. They're actually going to be talking about BMI a little bit in here. All right? We're not going to do any BMI programs, but just so you know. So they've got a person object, and they say every person would have this stuff. A name, an age, a height, a weight, an eye color, and a gender. All right? What eye color would possibly have to do with BMI is way beyond what I know. But when you think about it, the other stuff in here could be important. All right? The behavior is what an object can do. So if you look in here, they say you can calculate your BMI and print stuff out. Okay, fine. Every object has state. State is where the object is right now. So for instance, if I was teaching this class 10 years ago, my height would have been 6 feet tall, my weight would have been about 190 pounds. All right? Now that it's years later, my height's the same, but my weight's a lot more than that. All right? So my state has changed over time. All object-oriented languages have to have 3 different principles, 3 different things they want you to do. If you remember, if you look up on the screen here, I just showed you this, right? All right, and I went to File Writer, and if you drill down far enough, they even usually give you an example of how to use it. Okay, but the point of this is I can use this because it's something that the people who created Java wrote. I don't have to know how it works internally, do I? I just have to know how to call it and what it's supposed to do. If I call it the right way, it should work. Well, what does that have to do with anything? Well, the innards of that, so to speak, the implementation is encapsulated or hidden from me. All right? Inheritance. We've talked a little bit about that in the C# class. And I gave you the example. I gave this example to the first-year people this morning. Man with big nose marries woman with big nose, has baby. Chances are pretty good baby has big nose. May not happen, but usually it does. Baby either A, lives with big nose, B, gets a nose job. It's not like they can just grab their nose off and put a different one on. You can do that in Java. If you don't like the way, so if I create a class that's called employee, and every employee has some kind of a method in there, then I create a class underneath that that's called commission employee. I can go and override anything that the employee created. I can override it in the commission if they do it differently. All right. Finally, there's polymorphism. So this will be the first time you'll see this semester. Not like it's a big thing, but just to show you quickly, I'm going to type here animal, dog, cat, pig. And just one more time, just to do this, we'll put in here, I don't know, lab, gold lab and a black lab. All right. This is what's called an object hierarchy. All right. It's a 3-level object hierarchy. Animal is level 0, dog, cat, and pig are level 1, and gold lab and black lab are level 2. Make sense? All right. I can come up here and I can define stuff up here if I want to. I could define a method up here that's called speak. And as you'll see pretty soon, I can make that what's called an abstract method. If I declare it and there is an abstract method, what that means is all these things have to have their own speak method. Does that make sense? But I think you'd agree, if I tell a dog to speak, I'm going to get something different than if I tell a cat to speak. It's going to give me something different than if I tell a pig to speak. All of them can react to a speak method, but they can react differently based on the type of object they are. That's what polymorphism is. All right? Maybe not the best explanation, but it's better than what you'll get in a lot of books, to be honest with you. Here's the Java reserved words. Look on the screen. This is just A through P. And there's the rest of P through W. There's about 50 or so reserved words. What you'll know, because we'll be using an IDE, is when you type in a reserved word, it'll change to a different color. You can't use that word then as one of your variables. So for instance, super is a keyword. Well, I could call it super 1. That's not a keyword. Or Superman, or Superwoman, or whatever. All right? All right. So this is the kind of thing we're going to create. And I know it looks different from what you've seen before. You're going to have at the top of each program the word package followed by your package. And it's like I mentioned before with Matt. So Matt will say something like package, space, org, dot, inside Rankin, dot, Matt Purcell. Make sense? I want you to use that for a lot of reasons, but one reason is I can always go to the top of your program and know who wrote it. All right? Then, after your package statement, you can only have only one of these per Java program. All right? Then we've got an import statement. Do you remember in the C# class at the top where we used using statements? That's what these are. All right? Then you've got something like typically it'll be public class, then the name of your class. Everything's within curly braces. So this is the kind of way that you're going to write a class. Comments are done exactly the same way that we've been doing them. / for a single line comment, / and / for a multi-line comment. Packages, I already showed you those, but we're going to, and this is where they mentioned this reverse domain name, so I'm not going to go over it anymore. All right. Going all the way down to page 16. Classes can have two different types of members, variables and methods. Do we have to go through this? You all know what a variable is, correct? Now, you may or may not remember this from C#. Remember public and private? Java has public and private also, but it has two more things. It has public, it has private, it has protected, and it has something called package or default. We're going to get into all of those as we go on. Public means basically it's available everywhere. Private means it's only available within the class. Protected means it's available within the class and anything that inherits from that class. And package means anything in the package it's available to. The default is package. Look up on the screen if you would, please. Here's an example. There's a person class. There probably is not a whole lot in there that's surprising to you. When we created strings in C#, we used a little s. Here, it's a big S. May not sound that important, but it is. String is not a data type. It's a class. All right? In fact, one of the questions I think you're asked on one of those tests, I could be wrong, but I thought you were. Well, hopefully he doesn't need that. Let's see, we've got byte, we've got int, short, long, double, float, Boolean, and char. These 8 things right here, these are referred to as the Java programming language primitive data types. Anytime you create a variable of any of those types, it can only hold one thing at a time. That makes sense? So I can come in here and say int age equal 21. Later on in my program, I got a birthday. I can now say age equal 22. Totally legit. Not a problem doing that. All right? But this one is basically gone now. It's been replaced with this one. All right? When you write methods, what you're going to find here, please again look up on the screen. Notice how your data typically is private. Most, if not all, of your methods are typically public. They don't have to be, but they usually are public, your methods. In fact, if you want a one-sentence definition of object-oriented programming, it's using public methods to manipulate private data. That's what object-oriented programming is. Every time you go and create a new object, you end up calling the class's constructor. Believe it or not, you may or may not remember, you heard this conversation. You heard this stuff in chapters 9 and 10 of the C# class. But then it kind of went away. Well, it's coming back now because you're going to use this all semester. Even when we get into the Android stuff, you're still going to be using it. So look up on the screen, please. Notice the name of the class is person. Would everybody agree with that? Public class person. When you write a constructor, it's got to have the same name as the class, but you don't put the word class in there. You don't give it a return type. Not only that, if you look, there's something here that says public person, and there's something here that says public person. All right, so there's two of the same things with the same name. That's what's called right there. It's an overloaded method. What's different between them? What goes in the parens. This one has nothing. This one has a string, an int, an int, an int, a string, and a string. What that means is if you want to create a person this way, you've got to pass in a string for their name, an int for their age, an int for their height, an int for their weight, a string for their eye color, and a string for their gender. Does that make sense? You're going to see this stuff very soon. This one you pass in nothing. You can create any methods you need to create. In fact, it won't be this week, but we'll spend a lot of time next week on what are called Java getters and setters. And ideally, by the end of next week, you'll have a good idea of how those work and how they're used. On the bottom here of page 19, see this? Static and instance method. Just to keep it as simple as possible. Static means there's one and we all share it. Instance means we all have our own. So for example, for a person, each person would have their own height, their own weight, their own eye color, their own hair color, etc. But if every time I created a new person, let's say I had a counter, I called it person counter. So I create five persons in here. I create one for each one of you. Now that person counter is equal to 5. Does that make sense? I only have one of those. So static means one that's shared. Instance means you each get your own. They got some more Eclipse stuff here that I'm not going to be going over with. Or going over it all. So here's your variable types. Are there any questions on those? Anybody have any questions? When you are debugging a program, this is up to you. You can put in the equivalent of like a print statement, all right, at any time. It's a little different. You're going to see it already today, all right? Or you can do what's called logging. What will happen is when we go, I'm going to bring this up just so you see it. I'm bringing up IntelliJ right now. And I'll grab that. That's fine. Of course it's not. Well, I'll do it in a way. There, create a new project. This is what we're going to do. If you all watch for a second, this is what we're going to be doing a little later today. Bring up IntelliJ. Over here, we won't have any projects, or you probably won't, so we'll create a new project. All right? We're not going to worry about the Kotlin stuff. We're not going to use that, at least not right now. Should be set to Java by default. If it's not, you'll click on Java, then you'll click Next. You don't want to create it from a template, so you'll create Next. Then you give your project a name. That's going to be basically the name of the folder that holds everything. So what I'm going to do is I'm going to literally create one here. I'm just going to call it Test Project, and I'm going to create it right on my desktop. All right, so it's saying create a project named test project and create it at the desktop. Does all that make sense? All right, now I click finish. And watch how this changes. Okay? It'll take a second to fill itself up, but it will. There we go. Or not. Oh, I should never have. Oh, okay. Desktop. Okay, it called it desktop, which screwed everything up. Let's close that. Start it again. You know what? I will just come in and I will open one up that I've already created. This I'm going to show you. Then we'll take a break. But I'm going to show you the first one that we're going to create. All right? So, now I've got it hung. So again, I'm going to show you right now the first one that we're going to create as a class after the breaks. Sometime today. So, I don't want to load a project. It's going to load this junky one I just created, possibly, but File, Close Project. All right. So, I'm going to open up an existing project. I think this is important just to show you the stuff that we're going to be doing. Now, this first example is actually a very, very, very simple example. All right, it may or may not look like it as we get through it, but it is. All right, this Java trail is created. Assignments. Created. There we go. Payroll. Number 1. Okay. So this is the first one that we're going to create as a class. I'm not even going to ask, does it all make sense? But if you look on the top, everybody see this? Remember, I have a different email address than you. Mine is jpscott@rankin.edu. So the name of my package is edu.rankin.jpscott. All right? So when I created this, I created a package, and that's what I called it. Then I created a class in here called Payroll. All right? And basically, all it gave me was this right there that you see in blue and this. That's it. So I added the rest of the stuff. Every Java program someplace has to have a main. Well, there's my main. All right? I have about 6 or 7 variables in here, maybe 8 or 9. I don't know. They should be pretty obvious what they are when you take a look at them. All right? And then I just print out what they are. That's it. So if I go to run this, and if you look down on the bottom of the screen here, it'll come up. It'll take a second. There. There's the output of my program. Everybody see that? I mean, it's not like, gee whiz, oh my God, how cool. I don't mean that. But what I can do is I can write here, or if I want to, I can write to a log file. All right? We're going to do a little bit with that, but not today. Some more Eclipse stuff on getters and setters. We will be doing this. When you create a method and you call it, it's what's known as invoking a method. All right, it's a method call. You've done things like this before. Please look up on the screen here. We're creating a person and we're calling that person P. I mean, we could have called it Peter, whatever, it doesn't matter. Then we say p.setName. This is calling the setName method, and that's what we're passing it. All right, and again, you're going to be doing this already today. When I taught this last year, what most people said at the end of the first week is, this is almost exactly the same as the C# stuff we did. Yeah, but then it'll get different. All right? Okay. Strings, do you remember how we glued two strings together? Remember that? How we used the plus sign? You can do that, or there's an actual operator called concat. Remember chaining? You probably remember it better from last semester, but chaining that we did back with jQuery, the name of a method, dot, the name of another method, dot, the name of another method, you can do that in Java. Here's your operators. Do we have to go? I'm asking you. Please tell me. Do we have to go over any of these? Are there any of these right here that you don't remember? You know, addition, subtraction, multiplication, etc. Now, some of these, we've done plus plus, we've done plus minus. These are just those assignment operators. Plus equals, minus equals, times equals, divide equals, modulo equals. Okay? How about these? Greater than, less than, greater than or equal to, less than or equal to with a double equal sign. Okay? You know how to do an if statement. It doesn't change here. Same rules we've used. You know how to use an else statement. Again, look up on the screen. All that code that you see up there should make sense to you. I'm not saying you know what ret is, and etc. But the point is, the flow of that program should make sense to each and every one of you as far as what's going on in there. It's checking to see if you're a male. If you're a male, it's returning whatever your height is plus 2. Otherwise, probably you're a female. All right? I mean, I know that sometimes there's other designations, but if you're not a male, you're just returning the height. That's all. Same ternary operator, question mark, colon, that we've used before. The loops are the same. There's a for loop, there's a while loop, there's a do while loop. They're written exactly the same. Again, please look up on the screen here. See that? Is that anything new? I don't think so. You know how to write for loops. You know how to write while loops. There's a while loop. You know how to write a do while loop. You know how to terminate loops using a break statement. You know how to terminate the current iteration of a loop using the continue statement. We've done all this. They mean the exact same thing as what we had been using in other classes. All right? When you create an array, look up on the screen here. If I want to create a brand new array of integers, see how we do this? Int, bracket, bracket, integers equals new int 5. So what will that be? First one is integers 0, then integers 1, then integers 2, then integers 3, then integers 4. Same thing that we've had in other classes. If you want to initialize the array when you create it, you can do it like this, or you can do it like this. It really and truly doesn't matter. You know what an index is. The length thing will give you how many elements are in the array. This is where it's new, sort of. You can create an array of objects. We're only going to write one program in Java. We're going to spend one part of one period where we're going to write a Java program that's going to be GUI. Everything else is going to be right from the command line. All right? When we do that, you'll see some of this stuff. Here's a new term. You haven't heard this before. Boxing and unboxing. Okay? If I create a variable, I don't know if I wrote one like this before or not, but yeah, this right here. That's a simple variable. Does that make sense? If I try to write age dot and I want to do something with it, I can't because it's a simple variable. All right? But what I can do is I can write this, then I can come through here and I can write integer with a capital I, and I can write I equals age. Now, if I type I dot, there's a whole bunch of stuff I can do. All right? Because what I've done now is, that's what they call it, you put it into a box, and instead of treating it like a simple variable, you now treat it like an object. So you could put it in a box, or you could take it out of a box. So you can box it or unbox it. And they mention that in here. All right? Is that big a thing? Not for what we'll be doing. No. A list. I don't know if you remember this. Give me 5 more minutes and then we will take a break. But you may or may not remember this. When we worked with JavaScript, remember that a year ago? You're working with JavaScript and you're creating an array. An array can hold anything. I could put a name in there and then I can put a number in there, etc. Yes, no, remember, yes, okay. Java, every element in the array has to be the same type, everything. So if I create an array, it's an array of ints, or it's an array of booleans, or it's an array of whatever. I can make an array of strings. All right? Now, if I do that, and I create an array and I say it's got 5 elements, I can't make it bigger. Once you create an array in Java, it's fixed at that size. So sometimes what people do is, instead of creating an array, they create an array list. Because something with list on the end can grow and shrink as the program's running. We'll look a little bit at things that are called sets. A set is the collections construct that contains unique elements. In other words, there can't be duplicates. All right? You can put thousands of things in there because you know that none of them are exactly the same. Put something in it, see how big it is, get something out of it. You can work with maps. I don't know if we'll do anything with maps this semester or not, but it says you can associate an object, a key, with a value. Okay, we've done similar stuff to maps. We've used associative arrays, for example. This last section, you can read this on your own, but you should know what a jar file is if you look up on the screen. Typically what happens, and we'll be doing this when you get done with your Android apps, is you'll take everything and kind of put it together and zip it, for lack of better words. When you zip it, you put it into a jar file, which is Java Archive. What's cool about a jar file is jar files automatically open up when they needed to be opened, and they only grab what they need. So they're a lot more powerful than just a zip file. Right, just about finished. All right, finally, to write good Java code, try to keep your classes small. They shouldn't be, ideally, there's no exact limit. Name things carefully so people know what you're doing. Not only should your classes be small, each method should be small. They say should be the size of a page. I think I've shown you this before. One of the students showed me this, and they thought it was funny. If you look on the screen, they said, "Hey, Mr. Scott, look, you said they can only be a page." Well, mine's a page. See, I only have to make it, when I make it that big, it fits on a page. No. Normally 12-point font or whatever, not this big, but something like this, all right, should be able to fit on a page. Not always the case, but you should try to shoot for that. Use a consistent style, and that's it. So we're going to take a break. It's 1:49. Let's come back at about 2:03. We're going to go over the second half of this. Then we're going to look at the first Java trail. Then we're going to write code.